Let's take a look at Typhoon Nanmadol, its unique weather patterns, and the potential damage to buildings. Nanmadol caused significant damage across Japan. First, let's review the typhoon's path and strength. Nanmadol formed as a tropical depression over the southern waters of Japan on September 13th. By the following day, it had intensified into a typhoon. On September 16th, fueled by high sea surface temperatures, Nanmadol rapidly intensified, reaching a central pressure of 917 hectopascals. The typhoon continued moving north and made landfall in Kagoshima Prefecture on September 18th, with a central pressure of around 950 hectopascals. Even after landfall, it maintained its strength as it moved northward. On September 19th, near Ishikawa Prefecture, it transitioned into an extratropical cyclone. Next, let's look at the regions impacted by strong winds. The areas highlighted in yellow and red represent regions where maximum gusts exceeded 30 meters per second, or 67 miles per hour. According to historical data, wind speeds above this threshold can cause damage to buildings. As the typhoon intensified, strong winds spread across a vast area over the ocean. By September 18th, powerful winds had already reached Kagoshima, where the typhoon made landfall. After landfall, strong winds extended across a wide region, including Miyazaki, Kumamoto, Oita, and Fukuoka Prefecture. Next, let's turn our attention to areas affected by flooding. Flooding is closely related to 24-hour precipitation totals, with areas where precipitation exceeded a certain threshold are highlighted in yellow and red. The rainfall pattern followed a similar trend. As the typhoon developed, heavy rainfall was concentrated around its eye. While Kagoshima experienced significant rainfall, even heavier rain was observed in Miyazaki and Oita Prefecture. Heavy rainfall has also occurred in regions outside of these areas. Before diving into damage predictions, here's a look at the building distribution in the affected areas. The flashing regions indicate areas with a high density of buildings. This analysis uses a global building database. The total number of buildings by prefecture is represented on a map. From the bottom, Kagoshima has about 690,000 buildings, Miyazaki has 430,000, Kumamoto has 590,000, and Oita has 420,000. By combining building data with meteorological information and a prediction model, we estimate the number of buildings impacted by strong winds and flooding. The map shows the estimated number of damaged buildings. The areas shown in pink indicate regions with a high number of affected buildings. The percentages represent the ratio of affected buildings to the total number of buildings. The hardest hit area is Miyazaki, with around 68,000 damaged buildings. Following this is Kagoshima, with approximately 47,000 damaged buildings. Yamaguchi has 5,000 damaged buildings. Hiroshima has 1,000. Ehime has 4,000, and Kochi has 2,000. For a more detailed view, yellow bar graphs show the affected areas and the number of damaged buildings. Longer bars indicate higher damage counts within each grid. As you can see, the damage is not concentrated in just specific areas but spans across a wide region. Many of Japan's cities are located along the coast, and most of the damaged buildings are also found in these coastal areas. In Tokushima Prefecture, the Yoshino River flows in a straight line, with urban areas along its basin, where buildings have been affected. Except for Miyazaki and Oita prefectures, the damage in most other regions is primarily caused by strong winds. Thank you for watching. Don't forget to subscribe to stay up to date with the latest information.